Hi, I'm Jim White from Dell's End User Computing CTO office and lead architect for Project Fuse. It's said that creating Internet of Things or IoT solutions today can be difficult. Why is that? There are several reasons, but what in essence it comes down to are a few major challenges. First, sensors and devices don't speak a common language. Each communicate the data they have to share in a unique way, using their own format. Further, the protocols by which they communicate are many and varied. Some, such as the Modbus protocol, have been around since 1979. Some protocols like Z-Wave, which was started in 2005, are proprietary communication protocols. This leaves organizations wanting data from sensors and devices having to figure out the various communications mechanisms to all of their things. Wouldn't it be nice if there was a tool to help normalize all the data formats and protocols into a common data stream that enterprises and cloud systems could understand? The second challenge of today's IoT is that devices and sensors can produce a prolific amount of data. Organizations have to transport and store that data and then sift through it for valuable nuggets of intelligence. The more sensors, or the more profusely the things send data, the more networking and storage an organization must pay for. Often, the data being sent and stored, as in this thermostat example, is the same information over and over again. Wouldn't it be nice if there was a tool to help reduce the amount of data that needed to be transported, stored, and sifted through, sending only data that an enterprise needed, or whittling the data down to just meaningful events that could be quickly acted on? Finally, the last challenge is again a communications challenge, but in reverse. Devices and sensors and actuators do not have a common communications API which enterprises can leverage. When an organization wants to command a device or actuator, it must translate its request to the thing in the language it understands. The more devices and actuators, the more translation that needs to occur. Wouldn't it be nice if a system could provide a common command interface to all the things connected to an IoT system and allow an enterprise to send one command that gets automatically translated to all devices and actuators? Of course, the nice system alluded to in all of these IoT system issues, we believe, is Fuse. Fuse is a highly flexible platform independent software system for IoT gateways. Designed for Dell's gateway, but capable of running on almost any hardware and almost any OS to include Intel ARM, Linux, Unix, Windows, and more. Fuse collects the data from an array of devices and sensors and translates the data into a common format suitable for enterprises or cloud system consumption. It also provides an API to allow enterprise and cloud systems or any other software to easily send commands to any device without having to know the protocol or communication format of that device or sensor. Finally, it can help filter and collapse data collected by a thing to reduce network and storage cost. It even provides the means to have local edge analytics to react quickly to data it sees coming in from the device or sensor. Now for the best part of my job. Let's take a look at Fuse in action. First, allow me to log in to the local management console. Once logged in, I see, through Fuse's dashboard, an array of devices and sensors connected to Fuse. In the CTO lab, we've connected BACnet thermostats, Modbus proximity sensors, analog devices occupancy imaging cameras, PAT-Light signal towers controlled by SNMP, power meters and motors controlled by Modbus, and many more. Recall that Fuse helps to collect data coming in from this variety of devices and sensors. We could take a look at it. For example, the historical room occupancy count provided by the imaging camera. or the RPM speed of one of the variable speed motors connected to fuse. One of fuse's other main functions is to provide a command API in order to be able to command and control any device connected to the gateway. Here I'll set the speed of the Modbus connected variable speed motor to 1200 RPM. A simple rules engine based on the open source Drools package is set up to look for any speed exceeding 900 RPM on the motor. When it sees it, it triggers a red flashing light on a PAT light signal collar. All of this is happening on the gateway. Similar rules allow me to set off the amber light on the PAT light when the occupancy is sensed to be above 1 by the occupancy camera. Or I can have the motor shut off when something gets too close to the proximity sensor. That's a quick look at Fuse. I hope you enjoyed it, and please stop by the CTO lab in Austin, Texas for a better look at Fuse and to understand its architecture.